Welcome my student to my fourth lecture regarding the different doses calculation. So in order to calculate the dose, I have already discussed about the different dosage form, how to calculate the dose. So today the question is different. Now the problem is here that an adult patient who came to the hospital and he is diagnosed as a diabetic ketoacidosis. Set up an infusion for administering insulin intravenously at the rate of 0.1 IU per kg per hours, and the patient weight is 60 kg. So first of all, you will have to understand the questions, that what is the weight of the patient, and normally the dose which we are going to calculate it. So here's now the question is that an adult patient who is diagnosed as who is suffering from, you can say, diabetic ketoacidosis. So set up an infusion for administering, that is insulin. So as we know that insulins, now we are going to inject insulin intravenously at the rate of 0.1 IU per kg per hour. So these are 2 points. So as we know that, now we are going to calculate the total dose. So for total dose calculation, the weight of the patient is required and the dose which is already given in the literatures. So that is the total dose. As we know that the total dose is 0.1 IU per kg per hour. It will be multiplied with the weight of the patient. So it become how much? So it become the total dose, it become 6 units per hour per kg, you can say, body weight. So now I am going to mark here, this is a number passed, so to be noted here. Now the insulin vial, it contain 40 units per ml. So this is already given in the literature, in the label, so you can study it, that the insulin vial, it contain 40 units per ml. It means that on the basis of per ml, insulin vial contain 40 units per ml. Now take 40 units per ml from the vial and add it into 500 ml normal saline. So this is very simple, that you should take the 40 units per ml vial of insulin from the vial, and then it can be mixed, or you can say then it can be mixed with 500 ml normal saline. Now here is a mixing technique. So how we can then, it mean that 40 units per ml insulin must be, it should be dilute with 500 ml normal saline. As we know that 40 units, so they are present in 500 ml, because we are going to dilute 40 units in 500 ml. So in order to calculate it means that, let's suppose if 40 units, so they are dissolved or they are diluted in 500 ml. So 6 units, the total dose which are mentioned here, it will be equal to how much ml? If you are going to dissolve 40 units in 500 ml, so for example, the total dose becomes 6. So 6 units will be dissolved in how much ml? So this is very simple calculation. It will be cross multiply with 500. So 500 multiplied by 6 cross multiplications will be here, and after that it will be divided 40, so it becomes 75 ml. So what does it mean? That for 40 units 500 ml, we have dilute 40 units in 500 ml. So here in this case 6 units will be dilute in 75 ml. So this will be equation 2. So I will mark it here. Now let's see here. 6 units per hour is equal to how much ml? 75 ml, which can be calculated from this equation. So it means that now if ml per hours, if these hours can be converted into minutes, so it become equal to 101.25 ml. If hours they are converted into minutes. So this is very simple mathematical calculation. Now next step, this is second step. Now in third step, what we should do? So this point is clear, so that the infusion rate is 1.25 ml per minute. This point is clear that the infusion rate is 1.25 ml per minute. So after that, in third step, now is we know better that 1 ml contain how much drops? 20 drops. Is usually it contains 16 to 20 drop, but here I have mentioned 1 ml is equal to 20 drops. So in order to calculate it, 125 ml will be equal to how much drops? So this is a cross multiplication will be done here. 1.25, so it will be multiplied by 20. So cross multiplication will be done here, so it become 25 drops per minute. So if 1 ml contain 20 drops, so 1.2 ml of a drug contain how much drops? 25 drops per minute. So this is cross multiplications. Give insulin at the rate of 25 drops per minute. So this will be the answer. What was the question? That set up an infusion of administering insulin intravenously at the rate of 0.1 IU per kg per hour. So now in first step we have calculated the total dose, which becomes 6 units per hour, and after that in second steps I have calculated here, then I convert the 6 units per hour into how much? 75 ml per hour, which become 1.25 ml per minute. While in third step I have calculated, so the infusion rate is 125 ml per minute after converting him into from hours to minutes. So the final result is that the insulin we must keep the insulin at the rate of 25 drops per minute. So this is very easy to understand. Try to practice it on the white page. Inshallah, it will be easy for my student to understand it. Thank you so much for watching my lecture.